Good evening everyone. Is my audio and video clear? So we'll deal with electrical and EC questions for your exam from EMF subject. Someone please confirm the video and audio through chat box. So that we can further proceed into the questions. Is the video audio clear? Yeah. Thank you, Ashok. Thank you, Saga. Thank you. So let us start with the basics now. Most probable questions will be from basics. So I stressed more upon the basics, particularly in this session. Because the probability that you get questions from basics is very high. Okay. So let us answer the first one. Identify the scalar among the following. Identify the scalar. You can answer in the chat box. Identify the scalar among the following. Option A 0. Option B x. Option C x into ax. Option D 9. Scalar, Ashok. X into ax is not scalar. It's a vector quantity. So what is the scalar here? Anyone? What is a scalar here? See, most of the people think numbers are scalars. You're wrong. 0 and 9 are given here. These are not scalars. These are constants. Yes, Naresh. Correct, Vijaya. So what is scalar here? X is a scalar. X is a scalar. Option B is the correct answer. Next, pressure is what kind of a quantity? Pressure is what kind of a quantity? No. Maunika, X is scalar, okay? Fine. Pressure is what kind of a quantity? Please be quick. Pressure is what kind of a quantity? Pressure is defined as force acting in all directions. The pressure do not have any direction. Thereby, pressure is a scalar quantity, Naresh. That's why I am stressing on basics. Not only you, Naresh, so many people will think pressure is vector. But sadly it is not. Pressure is scalar quantity. Next, electric dipole moment is what kind of a quantity? Electric dipole moment is what kind of a quantity? Dipole moment is of two types. Electric dipole moment QD, magnetic dipole moment IA. Remember, both the dipole moments are vectors. No, Ashok, no. Both the dipole moments are vectors. Both electric dipole moment and magnetic dipole moment are vectors. So what's the answer? Option B is the answer. Got it? Electric dipole moment will move from negative charge. If I take an electric dipole, if you have a positive charge and a negative charge separated by distance d, it forms electric dipole. The direction of electric dipole moment is from negative charge to positive charge. It has direction, it's a vector quantity. And magnetic dipole moment, take the direction based on the Faraday right hand rule. Is that clear? Suresh, Janardhan, Rashekar sir will answer your questions, okay? Meanwhile. Yeah. Jilan, kindly inform Rashekar sir to answer their questions, okay? Tensor of rank 0 is called as a tensor of rank 0. Rank represents the number of directions. Rank 0 means 0 direction, scalar. Rank 1 means vector. Rank 2, multi-dimensional vector. A tensor of rank 0 is a scalar. Clear? Next. Ratio of any vector to its magnitude gives us, if I define a vector is something that has magnitude in direction, where AA is called the unit vector. So from this unit vector, AA is vector by its magnitude. So a ratio of vector to its magnitude gives you what? A unit vector. Option C is the answer. Current is what kind of a quantity? Scalar or vector? Current is scalar or vector? Please answer. Current is scalar or vector? Most of the people think that current is vector, but it is not. Current is a scalar quantity. The reason current is a scalar quantity because it does not obey vector addition. Even though current has magnitude and direction, still it is not a vector. It is a scalar quantity because it does not obey. It does not obey vector addition. Very important point. Clear? Current is scalar, whereas current density is scalar or vector. Current is scalar, current density is scalar or vector. The first thing you need to clear is current is not a vector. Current is a scalar quantity, first thing. Now my next question is, what is current density? It's scalar or vector? Current is scalar, whereas current density is a vector quantity. Correct, Vijaya. Now, the direction of cross product. If you do A cross B, mod A mod B sin theta AB. Theta AB is the angle between A and B into AN. So direction of cross product is along the plane formed by the vectors involved in the cross product, is perpendicular to the plane formed by the vectors involved in the cross product, both or none. Yes, Sagar, correct. Direction of cross product is always perpendicular to the plane formed by the vectors involved in the cross product. Option B is the correct answer. Correct. Dot product obeys which of these basic laws? Dot product obeys which of these basic laws? Dot product obeys which of these basic laws? Everyone answer quickly. Yeah. Yes, sir, correct. Dot product A dot B is equal to B dot A. It obeys commutative law. A dot of B plus C is equal to A dot B plus A dot C. It obeys distributive law. It does not obey associative because A dot of B dot C itself is not defined, because once you do B dot C you get a scalar quantity and you cannot do a dot product between a vector and scalar. Therefore, Sagar, you are correct. Associative is not possible. Therefore, 1 and 3 option D is the answer. Cross product obeys which of these laws? Cross product obeys which of these laws? In cross product, A cross B is not equal to B cross A, it is not commutative. But A cross B is equal to minus B cross A. It is anti-commutative. It is anti-commutative. Therefore, it does not obey commutative law. No, Sagar, no. Associative. A cross of B cross C. B cross C is one more vector. You can define A cross of B cross C. Most of the people think that they are equal, but not. It is not associative. You can verify. A cross of B plus C. A cross B plus A cross C. This is only possibility. So it is only distributive. Only 3. That is option C is the answer. Is that clear? Given R is equal to XAX plus YAY plus ZAZ. Del dot R is dash. We know del is dou by dou x of x plus dou by dou y of ay plus dou by dou z of az. And R is xax plus yay plus zaz. If you do del dot R, ax dot x is 1, ay dot ay is 1, az dot az is 1, dou by dou x of x is 1, dou by dou y of y is 1, dou by dou z of z is 1, 1 plus 1 plus 1, 3. Option D is the answer. The formula for differential volume in spherical coordinate system is if you go for spherical coordinate system, the coordinates are r, theta, phi. Differential length along r is dr. Differential length along theta is r d theta. Differential length along phi is r sin theta d phi. Is asking find the differential volume. Differential volume is just multiplication of all this. So what do you get? R square sin theta dr d theta d phi. So what's the answer? So what's the answer? R square sin theta dr d theta d phi. Option D is the answer. The unit of magnetic field intensity H is defined as N into I by L. Unit is ampere per meter. Option B is the answer. Unit of magnetic dipole moment. Magnetic dipole moment, for any dipole you have magnetic dipole moment, let me take an electric dipole first. This is an electric dipole formed by two charges plus q and minus q, separated by distance d, forms an electric dipole having electric dipole moment P is equal to q into d. Unit is coulomb meter. Similarly, if you take a solenoid, then you have magnetic dipole moment, which is I into A. where I is the current carried by the solenoid or the straight conductor and A is the cross-sectional area. The magnetic dipole moment is given by ampere meter square. The option C is the answer. Is it clear? Yes. What is the unit of surface current? Anyone? Current is of three types: line current, surface current and volume current. What is the unit of surface current? I am not able to receive any messages, I think. Are you replying? Line current given by I, surface current given by K, volume current given by J. Line current is given in ampere. Surface current is given in ampere per meter. Volume current also called as current density given in ampere per meter square. So I want surface current, ampere per meter. Option C is the answer. Unit of surface charge density. Unit of surface charge density. Charge densities are three types: rho L, rho S, rho V. Rho L is line charge density given in coulomb per meter. Rho S is surface charge density given in coulomb per meter square. Rho V is volume charge density given in coulomb per meter cube. Here he is asking surface charge density. Therefore, coulomb per meter square. Option B is the answer. Is that clear? Next question. Unit of electric dipole moment is. Unit of electric dipole moment is. I just told you. When you have two charges separated by distance d, it forms an electric dipole, and such electric dipole carries a dipole moment P, which is given as magnitude of any one of the charges into the distance q into d. Unit is coulomb meter. Option B is the answer. The nature of medium to allow electric field is given by. Very easy question. The nature of the medium to allow electric field is given by. Sagar. Electric field, Sagar. The nature of the medium to allow electric field. The nature of the medium to allow electric field is given by permittivity. The nature of the medium to allow magnetic field is given by permeability. I am asking electric field. Therefore, option A is the answer. Got it? Next. The value of dash is 1 less than relative permittivity. Anyone? Can anyone answer? The value of dash is 1 less than relative permittivity. relative permittivity epsilon r is given by 1 plus chi e. Can anyone tell me what is chi e? If epsilon r is 4, means chi e is 3. So value of chi e is always 1 less than epsilon r. What is chi e here? Chi e is called electric susceptibility, Rangarao. What is electric susceptibility? Sensitivity of the material towards electric field. Sensitivity of the material towards electric field. That means how fast, how quickly dipoles can be formed is decided by electric susceptibility. So what's the answer? What's the answer? Option C is the answer. Okay? Next. The following have same units. The following have same units. I line current, ampere. K surface current, ampere per meter. J volume current, ampere per meter square. Definitely they are not having same units. Rho L, rho S, rho V. Rho L coulomb per meter, rho S coulomb per meter square, rho V coulomb per meter cube. Definitely not. Whereas if you take IDL, I into DL, ampere meter, K into DS, ampere per meter into meter square, again ampere meter, J into dV, ampere per meter square into meter cube, again ampere meter. Therefore IDL, KDS, JDV, they all have same unit. So what's the answer? Yes, correct, Srinivas. Option B is the answer. Someone tell this. Can someone tell this? Which of them have the same unit? Rho S, surface charge density coulomb per meter square. D, electric flux density coulomb per meter square. P, polarization coulomb per meter square. They have same units. Rho S, coulomb per meter square. Electric field volt per meter. Surface current ampere per meter. Definitely not. This is also definitely not. H, magnetic field intensity ampere per meter. Surface current ampere per meter. Magnetizability ampere per meter. 1 and 4. Yes, Lucky, correct. Option D is the answer. From the statement of Coulomb's law, force between 2 point charges is. From statement of Coulomb's law, force between 2 point charges is directly proportional to the product of charges. Correct. indirectly or inversely proportional to the square of distance between them. Correct. Is always along the line joining them or the straight line joining them. Correct. So what's the answer? Option D is the answer. Is it clear? Yeah. Coulomb's law, obey Newton's third law. Is it true or false? F12 is equal to minus of F21. It obeys Newton's third law. Therefore true. Method of images, very important. Tell me the answer. Method of images can be applied for electrostatic fields, electromechanical fields, electrodynamic fields, electrochemical fields. What is method of images? When you have a point charge, separated distance d from a conducting ground plane, and if you want to apply Coulomb's law, which is not possible by a single charge, then you will remove this conducting ground plane and at equidistant d you take one more charge minus q. Now there are two charges separated by distance of 2d. Now you can apply Coulomb's law. This process is called method of images, which involves static charges. Therefore it can be applied only for electrostatic fields. So what's the answer? Correct. Rangarao, lucky, correct. Option A is the answer. So before applying method of images, if the distance between the point charge and the grounded plane is 2d, then after application of method of images, the distance will be before application 2D. What's the name? TS Engineers Academy. Before application, the distance between the point charge and the ground plane is 2D. If I apply method of images, in method of images we remove the ground plane, and at equidistant we take one more charge which is of opposite polarity. So now what's the total distance? 4d. So what's the answer? Option D is the answer. Clear? Is that clear? In Biot-Savart law, the value of K is, according to Biot-Savart law, the magnetic field intensity dH at a distant point is directly proportional to ideal sin alpha and is inversely proportional to r square. dH is K times of ideal sin alpha by r square, where K is a constant which is equal to 1 by 4 pi in SI units. Option D is the answer. The direction of electric field is always radial, non-radial, both, none. irrespective of charge distribution, electric field is always radial. It is evident E is equal to Q by 4 pi epsilon naught R square AR, indicating that E is always in the radial direction. Option A is the answer. The direction of magnetic field is the resultant of. The direction of magnetic field is a resultant of. Just now I explained you. Yes, Rangarao, correct. Just now I explained you. Bayard-Savart law. From this dH is equal to ideal sin alpha by 4 pi R square. You can write it as ideal cross AR by 4 pi R square. Therefore, the direction of magnetic field, is the cross product of current and radial. Current and radial, not radial and current, because cross product is not commutative, it is anti-commutative. They both are not equal. So what's the answer? Lucky got it. Yeah. The expression for electric force is given by Fe, which is Q into E, force acting on the charged particle Q in the presence of electric field E, which is called electric force. Option B is the answer. The expression for magnetic force, Fm. Magnetic force is the force acting on the charged particle Q, moving with velocity U, present in magnetic field B. Fm is Q into U cross B. But you know, if I am doing cross product, I can apply property of determinant, which is equal to Q into U cross B. Q into U cross B. They both are same. So Q into U cross B, correct answer. Q into U cross B, correct answer. B and C. Therefore option B is the answer. Lucky correct. Srinivas correct. If Fe is the electric force and Fm is a magnetic force, Lorentz force equation F is given by Lorentz force equation F is given by Fe is electric force, F is equal to QE. Fm is magnetic force, Q into U cross B. Total force acting on a charged particle in the presence of electric field and magnetic field. F is equal to Fe plus Fm. Q into E plus U cross B. What is this equation called? This is Lorentz force equation. So what's the answer? Option C is the answer. In magnetostatics, ideal is equal to KDS is equal to JDV. Is it true? Already I explained you all ideal, KDS and JDV, they have the same unit. What's the unit? Ampere meter. They're all equivalent. They're all equivalent. Therefore, option A is the answer. Clear? Now, read properly and tell me the answer. Rangarao, Srinivas, everyone read properly. Force on a charged particle is given by magnetic force. Fm is equal to Q into U cross B. Force on a current element is given by F. F is equal to line integral of ideal cross B. Force between two current element F is equal to mu naught I1 I2 by 2 pi r. This is given by what? Not Ampere's circuit law, but it is Ampere's force law. Force law. Ampere's circuit law is different. Ampere's force law is different. Remember. Option B is the answer. The distance between the loops L1 and L2 carrying current I1, I2, R is the distance between them, then force between the elements. Simply apply Ampere's force law. Force F is equal to mu naught times I1, I2 by 2 pi r. Already I have given here. So the force is directly proportional to the distance between the loops. False. Directly proportional to the product of currents. Correct. Inversely proportional to distance between the loops. Correct. Inversely proportional to square of distance. Correct. Wrong. So 2 and 3. So what's the answer? Option B is the answer. Any doubts? Yes. J is equal to dou D by dou T. J is equal to dou D by dou T represents which of the following? Conduction current density. What is conduction current density? J is equal to sigma E. Always remember, conduction current density depends on conductivity of the material. Convection current density. J is equal to rho VU. And always remember, convection current density depends on velocity of the charged particles. Displacement current density, J is equal to dou D by dou T, depends on time varying field. So J is equal to dou D by dou T represents what? Displacement current density. Represents what? Displacement current density. Therefore, what's the answer? Option C is the answer. The following current density depends on velocity of charged particle. Just now I told you. Which current density depends on velocity of charged particles? Please answer. Someone answer quickly. Which current density depends on the velocity of charged particle? Just now I explained you. What's the answer? Srinivas, Lucky. What's the answer? The following current density depends on velocity of charged particles. As I told you, there are three types of current density. Conduction current density depends on conductivity. Convection current density depends on velocity. Displacement current density depends on time varying field. Is asking the following current density depends on velocity of charged particles. Convection current density depends on velocity of charged particles. Therefore, option B is the answer. Consider a finite line carrying uniform line charge density rho L which is 5 coulomb per meter, mean angles alpha 1 is 30 degrees and alpha 2 is 60 degrees. Find electric field intensity E at some distant point P. And the distance is 10 meters. What's the formula for electric field intensity for finite line? Very, very important. Electric field intensity for a finite line E is equal to rho L by 4 pi epsilon naught rho of sin alpha 1 minus sin alpha 2 A rho plus cos alpha 2 minus cos alpha 1 A phi. Clear? So substituting alpha 1 is 30 sin 30 1 by 2 rho L is 5 by 4 pi epsilon naught, distance is 10, sin 30 1 by 2 minus sin 60 root 3 by 2 into A rho plus cos 60 1 by 2 minus cos 30 root 3 by 2 of A phi. This is 1 by 8 pi epsilon naught of this value. Option A is the answer. Clear? No. Consider an infinite line. Previously it is finite line. Now it is infinite line. For infinite line, electric field intensity E is equal to rho L by 2 pi epsilon naught rho A rho. Rho L is 5 coulomb per meter by 2 pi epsilon naught into 10 A rho. One by 4 pi epsilon naught A rho, which is 1 by 4 pi epsilon naught A rho. Is that clear? One second. So this is equal to 1 by 4 pi epsilon naught A rho. 1 by 4 pi epsilon naught is 9 into 10 power 9 A rho. Option B is the answer. Yeah, correct. Consider a finite line carrying current of 4.33 amp. The magnetic field at a radial distant point P is at radial point H is I by 4 pi rho cos alpha 1 plus cos alpha 2 A phi. Alpha 1 and alpha 2. Both are 60 degrees. H is 4.33 by 4 pi rho cos 60, 1 by 2 plus 1 by 2, 1 of A5. I need to find rho. This is 5. This is half of it, 2.5. This is a right angle triangle, 5 square, 25. This is rho. Rho square plus 2.5 whole square, 6.25. Rho square is 18.75. Rho is under root of 18.75, which is 4.33. 4.33 by 4 pi times of 4.33 into A5. 1 by 4 pi A5. So what's the answer? Option D is the answer. Next, a semi-infinite line carrying current of 20 amp. Semi-infinite line is extending from 0 to infinity on the positive x-axis. At radial distance rho is 5 meter. Is asking us to find the magnetic field for a semi-infinite line. H is I by 4 pi rho A5, 20 by 4 pi into 5 A5. H is 1 by pi A5. Option A is the answer. Next, an infinite line carrying current I is 10 amp along the z-axis. The magnetic field at the radial distance of 5 meter. Rho is 5 meter. Infinite line magnetic field intensity H is equal to I by 2 pi rho A5. 10 by 2 pi phi A5. 1 by pi A5. Option A is the answer. This is very interesting. Please try and answer this. A positive charge of plus x coulomb is enclosed in a surface, yes. Then the flux lines dash the surface. Enter, leave, both, none. Think and tell me. What's the answer? Rangarao, Srinivas, a charge of plus x coulomb is enclosed in a closed surface. Positive charge electric flux lines will radially go outward. How are the flux lines now? Are they entering the surface or leaving the surface? Absolutely leaving the surface. Option B is the answer. A Gaussian surface is one which is dash with respect to the charge distribution. A Gaussian surface is always symmetric with respect to charge distribution. Option B is the answer. Divergence theorem relates dash and dash. divergence theorem relates dash and dash. A divergence theorem relates dash and dash. According to divergence theorem, closed surface integral of A dot ds. No, Hari Prasad, wrong. According to divergence theorem, closed surface integral of A dot ds is equal to volume integral of del dot A dv. Divergence theorem relates closed surface to open volume or volume. So closed surface and volume. So what's the answer? Hurry. Option C is the answer. Not B, not B. Divergence theorem relates closed surface to volume. Hurry. So option C is the answer, okay? A cylinder of radius 5 meter is considered, it is kept in vacuum. The cylinder is kept in vacuum. Its radius is 5 meter. The flux cut by the cylinder. Vacuum means inside charge is 0. According to Gauss law, amount of flux cut by any closed surface is equal to the charge enclosed by the surface. Here charge enclosed is 0, therefore flux cut is also 0. Question number 15, option C is the answer. Yes, correct, Harish. Electric potential is defined as work done per unit dipole, unit force, unit charge, unit torque. Electric potential is work done per unit charge. Option C is the answer. Clear? Equation for EMF, electromotive force, which is voltage. VMF is equal to minus line integral of E dot dl. Relation between E and V. Option C is the answer. No, that is MMF, Naresh. Gauss law in true form is, always remember, true form means by statement. So according to statement, Gauss law is the amount of flux cut by any closed surface is equal to the charge enclosed by the surface. This is called true form. Option C is the answer. MMF is not valid in the regions wherever there is conductivity, magnetomotive force will fail. Magnetomotive force will fail. So wherever there is conductivity, it will not work. Option B is the answer. Equation that represents the conservative property of electric field is closed loop integral of E dot dl is equal to 0. Represents V is 0. Represents W is 0. Represents work done in moving a charge in the presence of electric field is 0. Represents the conservative property of electric field. Option B is the answer. Work done is represented by the formula W is minus Q into integral initial point to final point E dot dl. Minus Q into integral of initial point to final point E dot dl. Option A is the answer. No, Royal. A. Option A. Unit of MMF, electromotive force is voltage, whereas magnetomotive force is current. Electromotive force is given in volts, Magnetomotive force is given in amp turn. Amp turn, Naresh. Current through each turn. Not amount of current per turn. Poisson's equation in electric field is given by Poisson's equation del square V is equal to minus rho V by epsilon naught. This is called Poisson's equation. Option B is the answer. H is equal to XAX plus YAY plus ZAZ. Then find J. According to Ampere's law, del cross H is equal to J. So J is equal to det of AX, AY, AZ, dou by dou X, dou by dou Y, dou by dou Z, X, Y, Z, AX of this is 0, minus AY of this is 0, plus AZ of this is 0. So the magnitude will be 0. Option A correct, Naresh. Read this carefully. Cylindrical surfaces x, y, z are such that x is less than, y is less than z and having areas 20 meters square, 40 meters square, 60 meters square respectively carry uniform surface charge density rho s1, rho s2 and rho s3 and find the flux cut by a cylinder R where R is greater than x, is greater than y, is greater than z is dash coulomb. What's the answer? The amount of flux cut is equal to charge enclosed. Charge enclosed is surface integral rho s1 ds1 plus surface integral rho s2 ds2 plus surface integral rho s3 ds3. This is rho s1 into s1 rho s2 into s2 plus rho s3 into s3. Rho s1 is 2, area 22 into 20, 40 plus 4 into 40, 160 plus 6 into 60, 360, total 560 coulomb. So what's the answer? Option D is the answer. If electric field E is equal to XAX plus YAY plus ZAZ, then V at 1 comma 1 comma 1 is, V is equal to minus integral of E dot dl. From this dl is dxax plus dyay plus dzaz. E dot dl x dx plus y dy plus z dz, integral of it minus of x square by 2 plus y square by 2 plus z square by 2. Where x is 1, y is 1, z is 1, minus of 1 by 2 plus 1 by 2 plus 1 by 2, minus 1.5 volt. Option B is the answer. Unit of vector magnetic potential. Vector magnetic potential is given in Weber per meter. It is related to B as del cross A is equal to B. Option B is the answer. If A is equal to 2AX plus 3AY plus 4AZ, find mod of B. Del cross A will give you B. If you do the del cross A which gives you B, det of AX, AY, AZ, dou by dou X, dou by dou Y, dou by dou Z, 2, 3, 4. Now if you do the derivative, anyways you will get the magnitude as 0. Need not do. So option A is the answer. The potential at a point A is 10 volt. And potential at point B is 5 volt. Then VAB, VA minus VB, it's simply 5 volt. Option C is the answer. H is y square ax plus z square ay plus x square az. Magnitude of del cross H. Del cross H is ax, ay, az, dou by dou x, dou by dou y, dou by dou z, y square, z square, x square. Ax of dou by dou y of x square 0 minus dou by dou z of z square 2z minus 2z minus ay of dou by dou x of x square 2x minus dou by dou z of y square 0 plus az of dou by dou x of z square 0 minus dou by dou y of y square 2y at minus 1 comma minus 1 comma minus 1 minus 2ax plus 2ay plus 2az. Z is minus 1 minus of minus, that is plus 2ax, x is minus 1 plus 2ay, y is minus 1 plus 2az. So 2ax plus 2ay plus 2az is del cross H. Mod of it, under root of 4 plus 4 plus 4, under root 12, is 2 root 3. Option C is the answer. Which of the following does not represent the Maxwell equation? From inconsistency of Ampere's law, del cross H is equal to J plus JD, not B. So this does not represent Maxwell equation. So option C is the answer. Modified Ampere's law is represented by del cross H is equal to J plus JD is a modified Ampere's law. J is conduction current density sigma E. JD is displacement current density dou D by dou T. D is epsilon E. Dou by dou T is J omega in phasor form. Substituting sigma E plus dou by dou T J omega epsilon E. So del cross H is equal to sigma E plus J omega epsilon E. Option A is the answer. Which one of the following relation is not correct? Which one of the following relation is not correct? Del cross E is minus dou B by dou T, Faraday's law, correct. Del dot D is rho V, Gauss law, correct. Del dot B is 0, non-existence of magnetic monopole, correct. Del cross H is J plus dou D by dou T, not dou E by dou T. Therefore, option B is the answer. Is that clear? Any queries? You can ask. So, hope it's clear. I'm right. Thank you all for joining. Have a great day.